Stop. Look at that breadloaf van right there. That is the number one 4x4 on this list, and by the end of this video, you will understand exactly why. While American engineers were building bigger, louder, and more expensive 4x4s, the Soviet Union was doing something completely different. They were building machines designed to go where American trucks could not, survive what American trucks would not, and outlast everything the West ever made. And here is what should make every American truck fan uncomfortable. It worked. Every single time. These are 10 Soviet 4x4s built to destroy the competition. Most of them you have never heard of. All of them America had no real answer for. Let us go. Number 10. The GAZ-3937. Built in 1938. And that date matters more than any other fact about this truck, because in 1938 the Jeep did not exist. America had not yet designed its legendary off-roader. The drawings were not on the table. The military contract had not been issued. The concept had not been finalized anywhere in American engineering. And yet right there in the Soviet Union, engineers at the Gorky automobile plant had already built a working, production, four-wheel drive passenger car. Not a prototype. Not a concept drawing that might become a vehicle eventually. A vehicle that started, drove, and crossed terrain no standard car could follow. The GAZ-39 was built on the body of the GAZ-11 passenger car with a purpose-built four-wheel drive system engineered from scratch underneath. A 3.5-liter inline-six, producing 76 horsepower, driving all four wheels across terrain that two-wheel drive vehicles could not cross under any conditions. It had a two-speed transfer case, a front live axle, and ground clearance designed for a country with almost no paved roads outside major cities. The engineers did not wait for a brief or a government contract to tell them what the country needed. They looked at 11 time zones of largely roadless territory and solved the problem before anyone formally asked them to solve it. That discipline, solving tomorrow's problem today, is the entire reason this vehicle existed 3 full years before the Jeep was drawn on paper. Only around 36 examples were ever built. This was not a mass production vehicle. It was built for Soviet commanders who needed to cross rivers, forests, mud, and frozen ground in absolute confidence. The most famous person to sit behind its wheel was Marshal Georgy Zhukov, the general who commanded Soviet forces on the Eastern Front, outmaneuvered the Nazi war machine at Stalingrad and Kursk, and accepted Germany's formal surrender in May 1945. Zhukov used the GAZ-39 as his personal command vehicle throughout the entire war. While American generals were still waiting for the Jeep to clear procurement committees and enter production, the Soviet general who would end the war was already crossing the Russian wilderness in a 4x4 that nobody in the West even knew existed. America produced the Jeep and received all the credit for inventing the military off-roader. The history books remember the Jeep. They almost never mention the GAZ-39. But the production dates do not lie, and they never will. The Soviets built a four-wheel drive vehicle first, and the man who used it won the biggest land war in human history. Every single time someone tells you the Jeep invented the 4x4, remember one number: 1938. The GAZ-39 was already crossing ground the Jeep had not yet been designed to cross. It is the quiet proof that in engineering, being first matters. And the Soviet Union was first, 3 years before anyone in America had drawn a single line of what would eventually become the Jeep. That is not a footnote. That is the opening sentence of the real story. Number 9. The GAZ-39. This is where the Soviets stopped being ahead of the curve and started being in direct competition. By 1952, America had the Jeep CJ, the most iconic off-road vehicle on the planet. Beloved, battle-proven, exported across the world. And the Soviet Union looked at it, studied it carefully, took it apart in operational conditions, found every weakness it had in real field use, and built the GAZ-39 to beat it in every situation that actually mattered to an army. Not on a showroom floor, not in a magazine test, in the field, in real terrain, in the conditions where a vehicle either performs or fails permanently and gets abandoned. The The GAZ-39 ran a 2.1-litre four-cylinder engine, producing 55 horsepower, with a 2-speed transfer case, giving a proper low-range gear for demanding terrain. Not a powerful machine by any measurement. But power was never the Soviet engineering brief. The requirement was a 4x4 that could be driven by anyone with basic military training, repaired with tools a soldier already carried, kept running in temperatures from +40 to -40, and operated indefinitely without requiring a workshop or dealer network within several hundred kilometers. The GAZ-39 achieved every requirement with mechanical simplicity that made the Jeep look complicated. Fewer components meant fewer failure points. Fewer failure points meant fewer vehicles stranded in the places where stranded vehicles were most dangerous. Over 600,000 GAZ-69s were built between 1952 and 1972. That production run demonstrates with absolute clarity how the Soviet system valued what this vehicle provided. But here is the part that deserves the most attention. Over 40 countries around the world chose the GAZ-69 as their primary military and utility off-road vehicle. Not because they were Soviet clients with no alternatives. Many had full access to Western equipment catalogs, including the Jeep CJ. They chose the GAZ-69 because when both vehicles were evaluated side by side in actual operating conditions, real mud, real mountains, real jungle, real desert, the GAZ-69 proved more reliable, more maintainable, and more capable of staying in operation when the environment was hostile and the support infrastructure was absent. The Jeep needed dealer-level maintenance and spare parts shipped from American warehouses. The GAZ-69 needed a determined driver and a basic toolkit. In the developing world during the Cold War, that operational difference was not a minor convenience. It determined which vehicle armies actually ordered, deployed, and kept running for years on end. 40 countries made that comparison and chose the Soviet truck. That was not politics. That was engineering making the decision. When the history of Cold War off-road engineering is written honestly, the GAZ-69 deserves a chapter of its own. Not because it was the flashiest vehicle or the most powerful, but because 40 countries around the world tested it in their actual terrain, compared it to everything the West offered, and chose it. In engineering, there is no higher verdict than that. Number 8. The UAZ-4303. And this entry does not come with a dramatic combat story, a famous general's name, or a world record production number. What it comes with is something more powerful than all of those combined. A design philosophy so fundamentally sound that it has kept this vehicle in continuous production for over 60 years, and a reliability record in extreme conditions that makes comparable American light utility trucks from the same era look fragile by direct comparison. The UAZ-4303 was built by the Ulyanovsk automobile plant and launched in 1965 as a light utility 4x4 built around a single engineering principle the design team never deviated from. A field mechanic standing in the middle of nowhere with only the tools he carried on his back must be able to diagnose, fix, and drive away from anything that can go wrong with this truck. Not most things, everything. That was not a target or an aspiration written on a design document. That was the actual requirement that every component choice had to satisfy before it was approved for the final vehicle. The result was a 2.4-litre engine producing 77 horsepower, a dual-range transfer case for genuine low-range off-road capability, an 800-kilogram payload capacity that made it genuinely useful for carrying real supplies and equipment across terrain that would destroy a conventional delivery van, and a mechanical layout so logical and transparent that experienced drivers could perform major repairs without consulting any documentation at all. American light utility trucks of the same era were built around completely different assumptions. More power, more comfort, additional features, and the expectation that when something failed in service, you would contact a maintenance unit and wait for the correct specialist to arrive, with the correct equipment and the correct parts. That approach worked in Western Europe and South Korea, where American forces operated bases with fully equipped workshops and reliable weekly resupply. It worked considerably less well in the mountains of Central Asia, the forests of the Siberian Far East, or the permafrost tundra north of the Arctic Circle, where Soviet military and logistics vehicles regularly operated at hundreds of kilometers from the nearest support infrastructure. In those environments, the ability to fix your own vehicle with your own hands using equipment you already carried was not a design benefit. It was the operational requirement that decided whether the mission completed successfully or failed entirely in the field. The UAZ-4303 remained in production after 6 decades, not because of sentiment or the absence of alternatives. It remained in production because in the terrain and conditions it was designed for, the engineering got it right the first time, and nothing made it unnecessary. In the places the UAZ-4303 was built for, the ability to fix it yourself was not a feature. It was the mission. Number 7. The UAZ-969. Built by the Lutsk automobile plant in Ukraine, starting in 1966. The number that defines this vehicle above every other specification on its datasheet is 640 kilograms. That is the complete curb weight of the UAZ-969, fully equipped for field operation. For context that American truck engineers would understand, the engine block alone in a contemporary American full-size pickup of the same era weighed roughly that much by itself. Ford and General Motors were celebrating the output figures of their cast-iron V8S and dropping motors that individually matched the total weight of a complete, fully operational Soviet 4x4. America was building heavier and calling it progress. The Soviets were building with engineering discipline. And the result was a vehicle that could do something nothing in the American 4x4 lineup could replicate. The engine was a MEMZ 969, an air-cooled V4 displacing just 887 cubic centimeters, producing 30 horsepower. On any American specification sheet of the period, that number reads as an embarrassment. In operational reality, it was precisely the right amount of power for a 640-kilogram vehicle with four-wheel drive, independent suspension, and an amphibious capability that no comparable American off-roader of the same period came anywhere close to matching. Because the UAZ-969 could cross rivers, not wade through shallow fords at walking pace with its wheels on the bottom. Cross rivers, drive to the bank at normal speed, enter the water, and propel itself across open water using the rotation of its own wheels against the current, while the sealed underbody provided the buoyancy needed to float. No conversion required, no specialist equipment, no preparation sequence. You drove toward the water, and the vehicle swam to the other side. This was not a fortunate side effect of the vehicle's exceptional lightweight. It was the primary engineering requirement that the entire development program was built around. The UAZ-969 was developed specifically for Soviet military medical evacuation units who needed to reach casualties in terrain that conventional vehicles could not access. Flooded agricultural land, swamps, river-crossed ground, steep hillsides with no road surface of any kind. American medical units in equivalent terrain waited for engineering support to construct crossings or locate fordable points before they could reach casualties. Soviet medical units drove the UAZ-969 directly into the water and reached the far bank in minutes, with the patient already being loaded before American counterparts had finished radioing for a bridge team. In a combat medical context where every minute between wounding and treatment directly affects survival outcome, that river crossing capability was not a specification advantage on a datasheet. It was the operational reality the vehicle was designed to serve, and it served it every single time without exception. Number 6. The GAZ-66. And right here, I want you to pause for a second. What I am about to tell you should permanently change how you think about the Soviet versus American engineering rivalry. Not adjust your thinking. Change it entirely. Because the next fact involves a technology that the West publicly celebrated as advanced in the 1980s, and the Soviets were already fitting it as standard equipment in 1964. The GAZ-66 entered production in 1964. It had a ZMZ-66 V8 engine displacing 4.25 liters, producing 115 horsepower. It had a cabin-over layout, placing the cab directly above the front axle, which improved both weight distribution and off-road geometry compared to the conventional cab-forward designs that dominated American truck manufacturing at the time. It had a 2-ton payload capacity and genuine dual-range 4-wheel drive. All of that is genuinely impressive for 1964, but none of it is the fact that matters. The fact that matters is this. The GAZ-66 came with central tire. Inflation as standard equipment. Not optional. Not a premium feature on the top specification. Not a dealer-fitted upgrade you paid extra for. Standard. On every single unit leaving the factory floor. In 1964, central tire inflation, the ability to inflate or deflate your tires from inside the cab while the vehicle is moving, adjusting pressure in real time to match the terrain beneath you, is considered advanced off-road technology today. Overlanders and off-road enthusiasts pay significant money to retrofit it to expensive modern 4x4s. Western military vehicle programs spent years and substantial budgets developing, testing, and eventually standardizing it across fleets. The United States military did not implement central tire inflation as a widespread standard feature across its wheeled vehicle fleet until the 1980s, following expensive operational lessons from environments where tire pressure management proved to be a critical capability gap. Soviet drivers had been operating it as a matter of completely ordinary routine on the GAZ-66 since 1964, 19 years before the Americans caught up. Lower pressure for deep mud to increase tire footprint and improve flotation. Higher pressure for rock and compressed ground to prevent punctures and improve steering response. Different settings for sand, for snow, for wet clay. The GAZ-66 driver adjusted all of it from the seat without stopping, without getting out of the vehicle, without losing the forward momentum that could mean the difference between crossing an obstacle and being buried in it permanently. I said pause once. Pause again. 1964. Standard. Not optional. The Americans were competing on engine displacement and chrome. The Soviets were fitting technology the West would not standardize for another 2 decades and calling it basic equipment. The GAZ-66 stayed in production until 1999. 35 years. Nothing available made it unnecessary. Think carefully about what that means. Number 5. The GAZ-3937 Vodnik. Before going through what this vehicle can do, consider a question that has a revealing answer. Why did the United States military fund and operate entirely separate vehicle programs for amphibious assault, Arctic terrain operations, desert mobility, medical evacuation, troop transport, and forward command? Different chassis, different drivetrains, different spare parts inventories, different crew training requirements, different logistics chains, different maintenance manuals, entirely different procurement budgets, all running simultaneously through the Defense Acquisition System. Why? Because the American philosophy of military vehicle design was to build a dedicated specialist for every operational role and absorb the resulting complexity and cost as an acceptable and unavoidable price of capability. The Soviets asked a different question entirely. What if one vehicle did all of it? Then they built one. The GAZ-3937 Vodnik, Vodnik means water carrier in Russian, was developed in the 1990s and entered Russian military service as a genuine all-domain, 4x4 with no close Western equivalent anywhere in the NATO inventory. It is fully amphibious using dedicated waterjet propulsion, not shallow wading capability at reduced speed, with the wheels partially on the bottom, but genuine open water swimming at operational crossing speed, with full directional control from a waterjet system that operates completely independently of the road wheels. It has nuclear, biological, and chemical protection built into the standard body configuration. Full overpressure sealing and filtered air supply as a baseline on every production vehicle, not as an expensive specialist variant requiring additional procurement. It operates on low-pressure all-terrain tires with 500 millimeters of ground clearance, handling snow, swamp, sand, and deep mud without any adjustment required from the driver. Its modular body architecture means the same chassis accepts troop carrier, ambulance, cargo platform, or weapons mount configurations, in a field conversion that does not require returning to a base workshop or specialist fitting facility. The West was managing dozens of separate and expensive vehicle programs, each with dedicated funding, supply chains, and training requirements. Russia built one vehicle that covered the operational requirement of every single one of them. One chassis family, one drivetrain, one spare parts inventory serving every mission type simultaneously. The logistics simplification alone represents a strategic advantage in extended or high-tempo operations that is difficult to overstate. We are halfway through this list. Number 1 has been in continuous production since 1965 and is still being manufactured brand new in 2026. We are not done yet. Keep watching. That is the Soviet engineering philosophy in its most complete expression. One vehicle, every mission, nothing wasted. Number 4, the UAZ-469. This entry requires you to understand one specific piece of engineering, because once you understand it, you will immediately see why military forces across the Soviet Union, the Warsaw Pact, and over 50 countries in Africa, Asia, and the Middle East consistently chose this vehicle over every Western 4x4 available to them. The technology is called portal axles, and it represents one of the most significant practical advantages in off-road vehicle history, an advantage the American industry largely chose not to adopt, and paid for that decision in real operational terrain. On every conventional American 4x4, the Jeep CJ, the Ford Bronco, the Chevrolet Blazer, the International Scout, the axle shaft connects to the wheel hub at the same centerline height. The differential, which is the heaviest and most vulnerable component in the drivetrain, sits only as high from the ground as the wheel size permits. If you want more clearance underneath that differential, you fit larger tires. Larger tires give you height, but they also raise your center of gravity, alter the final drive ratio, stress the transmission and drive shafts, and cost money at every scale. That was the American engineering answer to the problem of ground clearance: spend more, fit bigger tires, and accept the trade-offs that came with the choice. The UAZ-469 used portal axles. The axle shaft does not connect to the wheel hub at the same height. Instead, it connects to a compact reduction gearbox at each wheel, and the wheel hub drops below the axle centerline. The differential and axle shafts sit significantly higher than the wheel centers, meaning the most vulnerable components of the drivetrain clear obstacles that would contact and destroy a conventional axle on the first impact. The UAZ-469 achieved 300 millimeters of ground clearance in completely standard production configuration. No modifications, no oversized tires, no special equipment of any kind fitted to the vehicle. The Jeep CJ of the same era achieved approximately 203 millimeters with standard equipment. That is close to 100 millimeters of additional clearance, nearly 4 inches, on a vehicle that weighed less and cost less than comparable American alternatives. In rocky mountain passes, rutted jungle tracks, and frozen terrain with hidden subsurface obstacles, 100 millimeters of additional drivetrain clearance is the operational difference between a vehicle that passes through and a vehicle that contacts the ground and becomes an immovable obstacle itself. More than 50 armies compared the options in their actual operating terrain and made their procurement decision based on exactly that engineering reality. The UAZ-469 ran from 1972 to 2003, 31 years. Because portal axles work, and nobody produced a cheaper or more effective way to match what they delivered in the field. Number 3. The Lada Niva, GAZ-3937. This is the vehicle I want you to remember most clearly when this video ends, because this is a story that should not have been possible, and it happened anyway, and every single fact in it is completely and independently verifiable. The Lada Niva launched in 1977 as a compact 4x4 designed for Soviet citizens who needed reliable transport on Soviet roads, which in large parts of the country meant no road surface of any recognizable kind. It ran a 1.6-liter single overhead cam engine, producing 64 horsepower. It had a permanent all-wheel drive system with a center differential, not a part-time four-wheel drive system engaged manually on rough sections, but a full-time system driving all four wheels continuously in all conditions. It had independent front suspension at a time when Land Rover was still fitting beam axles to its off-road vehicles and would continue doing so for years afterward. It had coil springs at all four corners, engineering that manufacturers in Britain and America considered genuinely advanced, fitted to a vehicle priced for ordinary Soviet workers who needed to cross a frozen field in February without getting stranded. The Western automotive press paid almost no attention when the Niva launched. It was cheap, it was small, it was Soviet. Range Rover had launched its premium 4x4 6 years earlier, and was considered the definitive benchmark for serious all-terrain capability. Nobody in the Western industry was particularly concerned about what a Soviet budget compact could do in serious competition. In 1983, a Lada Niva entered the Paris-Dakar rally. The Dakar was already the most demanding and prestigious off-road race in the world. Thousands of kilometers of Saharan desert, extreme heat, no support infrastructure, the best prepared vehicles from every serious manufacturer competing. Purpose-built rally machines, extensively prepared Land Rovers and Range Rovers, well-funded factory entries from European manufacturers, with years of Dakar experience behind them. The Lada Niva finished in the top 10 overall, not in a production vehicle class, not in a budget category. Overall, against everything the best funded and most experienced off-road racing operations in the world had brought to that start line. A Range Rover sharing the start grid cost approximately 5 to 6 times the price of the Niva. The Niva finished ahead of it across thousands of kilometers of African desert. The Lada Niva is still sold today as the Niva Legend, because some vehicles are designed correctly from the very beginning and never need to be fundamentally reconsidered. The racing world stopped laughing at the finish line in 1983. It should have started paying serious attention at the start line. The engineers who built it for Soviet workers never imagined it would finish the Paris-Dakar. But they built it so well that it did. That is what happens when you engineer a vehicle to the absolute limit of its brief, and nothing less. The desert found the limit. The Niva survived it. Number 2. The GAZ Tigr. 2006. This is proof that the Soviet engineering philosophy did not die when the Soviet Union itself did. When the USSR dissolved in 1991, the engineers at the Gorky automobile plant kept working. They watched what America was doing with its primary light military 4x4, identified precisely where that vehicle was succeeding, and where it was visibly failing under real operational conditions, and then built a direct engineering answer to both the successes and the failures. They called it the Tigr. Tiger. The name makes the intention clear, without requiring explanation in any language. The Humvee, by ZO, the high mobility, multi-purpose, wheeled vehicle, became famous during the Gulf War and defined the visual image of American military power projection for a generation. Footage of Humvees moving across desert terrain at high speed became the shorthand image for American military capability worldwide. For a period, that reputation was genuinely deserved, but by the late 1990s and into the 2000s, the Humvee's limitations in real forward operational environments were becoming both visible and financially costly. It was significantly heavier than its original light utility design brief had intended. Late model production units cost over $220,000 per vehicle delivered. Armor packages developed to counter IED threats added weight loads the suspension had not been designed to carry, reducing performance and accelerating component wear under operational conditions. Maintaining Humvees in forward combat zones required specialist mechanics and dedicated spare parts logistics that consumed resources the military would have preferred to direct toward the mission itself. The vehicle, intended to be fast, light, and mobile, had evolved into something that was none of those things in the environments where those qualities were most critically needed. The GAZ Tigr addressed those failure points directly and practically, built around a Cummins ISB 5.9-liter diesel producing 215 horsepower, a powertrain in widespread commercial use worldwide, meaning field mechanics in almost any operating theater could service it without specialist training. A single common chassis supporting multiple body configurations, patrol vehicle, personnel carrier, medical evacuation, command post. So one spare parts inventory and one training syllabus covered every variant. Genuine 4x4 capability with correct off-road geometry, allowing effective operation in the terrain conditions that had most clearly exposed the Humvee's design limitations. The Cold War ended officially. The competition between American and Russian military 4x4 engineering did not end with it. Russia kept building direct answers to American problems. Engineering-focused answers built on the same philosophy that ran through every vehicle on this list. The GAZ Tigr remains in active Russian military service today. Most of the Western world has never heard its name. That gap between real-world performance and public recognition has been the defining pattern of every single entry on this list. Number 1. The UAZ-452, the Bukhanka, the bread loaf. The van that appeared at the very opening of this video and made you think, that cannot possibly be number 1 on a list of vehicles that destroyed American competition. It looks like a postal van from a Soviet collective farm. It looks like something that belongs in the background of a Cold War documentary, not at the top of a serious engineering comparison. And that reaction, that immediate instinctive dismissal, is precisely the reason it earns this position. Because while every other vehicle on this list was built to win on a specification sheet, set a clearance record, or beat a specific competitor in a defined test, the Bukhanka was built to do the one thing none of them combined has managed: remain the correct answer for 61 years and still be manufactured brand new in 2026. The name Bukhanka is the Russian word for a loaf of bread. The van body looks exactly like one. A rectangular box set on 4 wheels, purely functional, with no concession to appearance, and no design effort spent on anything that did not directly serve the vehicle doing its job. First produced in 1965 by the Ulyanovsk automobile plant. Full-time 4-wheel drive with a 2-speed transfer case. Ground clearance of 220 mm in standard production form. Portal axles. The same system that gave the UAZ-469 its exceptional drivetrain protection, meaning the underside of the drivetrain clears obstacles that would contact and damage a conventional van axle. A body large enough to transport troops, carry a stretcher patient in full medical ambulance configuration, deliver supplies to a remote Arctic outpost, or serve as a mobile command post. All of it in one vehicle. All of it repairable in a field without a workshop and without documentation. Now think carefully about every American van from 1965, the Ford Econoline, the Chevrolet Sport Van, the Dodge A100. Think about where those vehicles are in 2026. Museums, restoration projects, rusted in fields. Not a single one survived into current production as a genuinely current vehicle. They were designed for the roads, conditions, and expectations of their era. When those conditions evolved and buyer expectations changed, the vehicles became obsolete and were discontinued by manufacturers who moved on. The Bukhanka was not discontinued. You can order a new UAZ-452 today in 2026 and receive a factory-fresh vehicle, not a heritage revival, not a limited collector edition, not a retro-themed modern interpretation. A current production vehicle that has been continuously improved in its powertrain and systems while preserving the fundamental architecture that worked correctly in 1965. The modern Bukhanka runs a ZMZ 40,906 2.7-litre engine meeting contemporary emissions requirements. The core architecture has never needed to change because it was engineered correctly the first time. 61 years of continuous production is the most honest engineering verdict that exists. When the right answer stays right for 6 full decades, you do not replace it. You keep building it. The Cold War ended over 30 years ago. These 4x4s did not. The Bukhanka is still being built. The Niva is still being sold. The engineering philosophy that produced all of them, build it right, build it simple, build it for real conditions, that never went away either. So here is the question I want you to answer in the comments. You have 500 miles of Siberian wilderness. No roads, no support, no rescue. You pick one vehicle. Do you take one of these Soviet 4x4s, or do you trust a modern American pickup? Drop your answer right now. I read every single one. And if you think there is a Soviet 4x4 that deserved to be on this list that I missed, tell me which one, because that is probably the next video. If you learned something new in this video, and I know at least one of these trucks surprised you, hit the like button right now. It takes 1 second and it helps this channel reach more people who love trucks as much as you do. If you are not subscribed yet, hit that subscribe button right now. I drop videos like this every week, trucks that rewrote history, engineering that should not have worked, and 4x4s that the rest of the world pretended did not exist. You do not want to miss the next one. Turn on notifications so you never miss a new video. The bell icon is right next to the subscribe button. One tap,